Good afternoon. This is for MCS Geometry, Lesson 74, which is located on page 490 in your text. You will be needing to have out and with you a sharp pencil, a ruler, a straight edge, a graph paper, and I would like you to go to page 490 and do the warm-up problems on your own. Please pause, and we will return. Number 1, reflections, rotations, and translations are all examples of transformations that are blank. Well, the meaning of it is same measure, and the word is isometries. It is perfectly fine if you say isometries, because iso means same and metry or metric is measure. Number 2 is to reflect the rectangle PQRS across the segment QR, or the side QR. So this is our reflection line. So here's where P starts, P prime flips over here, S goes to S prime, Q and R, Q prime and R prime are same. So the line of reflection or line of symmetry. Number 3 is in the book. To describe a reflection, you have to identify A, the amount of reflection, B, the center of reflection, C, the line of reflection, or D, all of the above. I am hoping that you chose C, the line of reflection, and that the rest was all there to confuse you. For your smart sheet, if on any warm-ups you have to look up or wait for this presentation to get your answers, please put the information on your smart sheet. Yes, so you can go back to it faster. The new lesson is called Reflections, and reflections are fun. Reflections are what we see and understand in a mirror. The shape of a door as it rotates on its hinges goes from one, its shape stays the same, but it changes where the outside, where some of the points are. Remember, a reflection is an isometry, meaning the image and its reflected image have the same shape and size. Just as you, walking around your house, changing your position, are an isometry. You have the same shape and size, but your position changes from lying down to standing up, from walking across the room, changing positions, as long as you maintain the straight up and down motion. So example 1 is a reflection across an axis, and the axis that I've drawn here has the x-axis and the y-axis labeled. This is the positive direction for x, this is the positive direction for y. I even took the word reflect, and I spelled reflect down here, and then so since the straight part of the R is the furthest away from the y-axis, the straight part is the furthest away. The pointy parts of the E are the closest to the y-axis, so the pointy parts of the E are the closest. These are all reflections of the word reflect. To reflect across an axis is the easiest, since all of our points are orientated so that they come out 90 degrees over, 90 degrees up, and so our perpendicular reference is already, we go straight perpendicular to the axis, straight perpendicular away. This distance between the axis and A will be the identical distances between the axis and A prime. So when we reflect across an axis or any line, we will find a mirror copy. Point B in this triangle is closest to the y-axis, so B prime is also closest to the y-axis. Letters, numbers, objects always appear backwards. Notice that the A to A prime coordinates. Let's look down at A. A starts at -7, 6 as its coordinate. When it comes over across the y-axis and reflects over, the -7 changes to a 7, and the 6 remains a 6. So it becomes from -7, 6 to 7, 6. Over 7, up 6. Over -7, up 6. So the thing to remember is not only that the numbers are the same, the sign changes always for one of them depending upon which axis you are going for. So initially, if we said that our pre-image point was xy, and we're transferring across the y-axis, it becomes negative xy. If that x was -2, then it becomes +2. This is true for reflections across all axes, but whether or not the x changes or the y changes depends upon which axes. So, here we've gone from A to A prime. I'm going to ask you to pause and go from A to A double prime by reflecting across the x-axis. What will we change? What are the coordinates of A double prime, B double prime, C double prime, if reflected into the third quadrant? A reminder that the quadrants are labeled first quadrant, Roman numerals, second quadrant, again Roman numerals, third quadrant, and fourth quadrant. They happen in the order that we learned them. We learned in counting from 0 and we counted up on it. When we were counting, we read from left to right. When we started adding another axis, we went up. We relate to up more than down. It's easier for it to jump than to fall into a hole. And then, so now this is our first quadrant that we ever learn, and then we go around counterclockwise. So what are the coordinates? Hint, same numbers, change some signs. So I wrote the same numbers, -7, 1, -2, 3, -7, 6. I wrote the 7, 1, 2, 3, 7, 6. And the other point is all points in the third quadrant are negative x. So it has to be -7, -1, -2, -3, -7, -6. You can go ahead and plot those, and you'll be able to see that reflection. Example 2 is now reflecting across a horizontal line, which we just did, but this horizontal line is not going to just change the signs. Example 1, we reflected upon the y-axis, which was a vertical line. Our pre-image was xy, our reflection was -xy. Then on the second example, when you went to A double prime, B double prime, C double prime, we reflected upon the x-axis, which is the horizontal line, which means if the pre-image is xy, then our reflected image is x negative y. Reflection across the y-axis, we change the x coefficient from positive to negative, and the pre-image to the reflected image across the horizontal line is x, and we change the y. So if u is 2, 6, u prime is 2, -6. So let's look up at the example in the book. Here we have u being over 2 and up 6. Now we can see that they want to reflect upon y equals 4. Well, how far away is 2, 6 from y equals 4? It is 1 square, or 2 points. So here we have 2 away, which means that its reflected value will be 2 points this way. Well, how can we write an equation or have a formula for figuring that out? Well, let's first remember that to reflect across this axis down here, the x-axis, it would be 2 - 6. So let's start with that, and we will come